Good morning to everyone present here. I am Sangeeta Lakshmi, working as Assistant Professor in EC Department at R.M.K College of Engineering and Technology. Today we are going to see the detailed routing under the Unit 4, which is called Routing Architecture. In previous class, we have started with the routing. Routing means it is creating the physical connections between any two components on an IC. How we have to make this physical connection means by depositing metal and metal segments through vias, antifuses or ramps depending upon the programming methodology we are using. Okay. So while we are making the routing, it has to meet some requirements. First one is timing, that is the maximum time required for a critical path, what is the clock speed, and it has to follow some design rules. Okay, so these are all the things we have to keep it in our mind while routing is takes place. The main objective of any routing is to choose very shorter length in between the two components, and also we have to avoid the congestions, and we have to use the very few number of programming switches in between the two components to decrease the delay, especially in the critical path. Okay, so routing can be performed in two phases. One is global routing and detailed routing. This diagram clearly shows how the routing is taken place, right? It is taken place in different layers. So more than 10 layers can be used to making the connection in an IC. So in this, if you want to make the connections, we want the horizontal track, vertical track, right, as well as wires. See, the green color line indicates the horizontal track, yellow color line indicates the metal track. So if you want to make the connection between two layers, we want the wires, right? We are going to see the detailed routing. In previous session, we have discussed about the global routing. The main difference between global and detailed routing is, in global routing, it will assign a loose path without considering the actual size of the each net. But in the case of detailed routing, it will assign the actual connection between the two blocks with considering the actual layout, geometrical size of each net. Okay, so the net which are the channel regions are used for this net, this information also it will give. Okay, so it also assign each net to specific routing segments in the channel as restricted by the global router. Already global router has given the information that these all the nets, for example, this is net 1. The net 1 has to go through this channel region 1. This is given by the global router, right? So, based upon this information, the detailed routing will make the connection between the two blocks by using net 1, right? Similarly, the design of detailed routing algorithm mainly depends on the routing architecture. So this routing architecture will be different for different FPGAs, right? The uh, going we are going to see the what are all the inputs we have to given to the detailed routing. See, first we have to given the net list. Net list means gate and its information. It is the information we have to given to global routing also, right? Next we have to given the placement. Placement means exact location of each block we have to give this information. So these also similar to the global routing. And third one is obstacles. Obstacles means already we told you, that is in the global routing algorithm we have discussed about the obstacles. Obstacles means this is the path in which we are making the connection between the two blocks, right? So this path we have marked as obstacle. In future, if you want to make the connection between any other two blocks, we should not cross this obstacle. We should not use this obstacle. That's why it is called obstacle. This information we are getting from only the global routing. So the output of the global routing is we will get obstacles. Okay. And fourth one is global routes, right? and the global will give you the, that is, it will provide the loose path. Which are the blocks we have to connect, through which are the channel pieces. That information is given from the global routing. And routing tracks, in which channel, which are the tracks we have to use. That routing tracks also given from the global routing. And design rules we have to follow. See, this design rules we are not following for the global routing, but detailed routing we have to follow. This is called DRC rule, design rule, checker rules. Okay. And the last input is we have to include the layer assignment. See, which are the layers are used for making the connection between the two blocks, whether it is layer 1, layer 2, or layer 3. So these all the layer information we have to given unless it is performed during the global routing, right? So these all the inputs we have to given to the detailed routing. Here we are going to see the detailed routing for row-based architecture. Then we are going to see the symmetrical based architecture. See, in the row-based architecture, routing, the total routing track. See here. See, the total routing track is divided into number of segments, right? So, the routing track in the channel is divided into several segments of various lengths. That means various length they are divided with the switches between the adjacent routing segments. So, this is the one segment, it is segment 2, segment 3, segment 4, like that we have. Right? If you want to make the connection between the two segments, we have to use a switch. So detailed routing in row-based architecture is reduced to segmented channel routing problem. That means this kind of architecture, row-based architecture, is called as segmented channel routing architecture because we are divided into number of segments, right? So if you want to make the connections between the vertical and horizontal tracks, we have to use these switches, right? See, in this horizontal line, we are using the switch to make the connection between the two horizontal segments. Suppose if you want to make the connection between the vertical as well as horizontal, means here also we have to use the switch, right? So wherever you want to make the connection between the horizontal as well as the vertical segments, we have to use the crossing switch. See this row-based architecture, it clearly shows that, see, this full region is called as the logic module because this kind of row-based architecture we are using in the Actel, right? In Actel only we are using this kind of architecture. In Actel, the basic programmable cell is called as logic module. So this is the logic model 1, 2, 3, 4, right? We have 4 logic models. And here also we have 5, 6, 7, 8, 9, 10, 11, 12. These are the logic modules. In between the two row of logic modules, we have the channel. See, this region is called as channel. So in this channel, we have 3 tracks. Thereby the channel density is 3. The channel density is 3. See, the total track is, for example, track 1 is divided into number of segments. It is segment 1, segment 2, segment 3, segment 4, 5, 6, 7, 8, 9. So we have divided into number of segments, right? And these all the number of segments are called horizontal segments, right? So in between two horizontal segments, if you want to make connection, we have to use a switch, right? See, this is called the switch, which can be used to connect the two segments. And if you want to make the connection between vertical tracks, this is vertical tracks and horizontal. Vertical segment and horizontal segments, we need to use a crossing switch, right? See, if you want to make the vertical as well as horizontal, we have to use cross switch. And if you want to make the two horizontal segments, we have to use a horizontal switch, right? See here, um, K segment channel routing method means it will give the information about the number of segments used to make the two blocks must be K. It's limited to K. Again, I'm telling K segment channel routing means the connection um, between the two blocks or component is restricted to maximum of K, right? For example, you can see from the model 1 to model 5, if you want to make the connection means this is one segment, second, four, third, fourth, it is 5. That means K equal to 5 is the maximum. You should not use more than this number of segments for making the connection between any two blocks. That is called K segmented channel routing. In order to reduce the delay, we have to follow this. And second one is detailed routing. Why we are going for this detailed routing for symmetrical array architecture is in the first row-based architecture, we are having more number of switches. Our main objective of any routing is to, in the initial class I told you, the main objective is to follow the three things. One is we have to use the shorter distance between the two blocks. The second one is we have to use transition free. And third one is we have to use the fewer programmable switch in between the two blocks, right? So, in the row-based architecture, we have many number of switches for making the connection between the two blocks. That will increase the delay. That's why we are going for the detailed routing. In the detailed routing for symmetrical array architecture. Symmetrical array architecture means it is a two-dimensional array logic modules interconnected by vertical as well as horizontal routing channel. See here, it is a 2D array logic model, right? 2D array of logic model. See, this is the module 1, module 2, module 3, like that. You have many number of 9 modules is shown in this figure, right? So, if you want to make the connection between the two modules, we have to use a vertical as well as a horizontal routing channel, right? So this is called vertical channel and this is called horizontal channels. If you want to make the connection between the vertical as well as the horizontal channels, we are using the block which is called switch model, yes, right? That's represented by yes. So in symmetrical array-based architecture, usually not all the vertical and horizontal tracks are populated with the switches. See here, these two last two lines are not connected with the switch, right? But in the case of row-based architecture, in all the crossing place, there will be a one switch. It is fully populated with the switch. But here, the crossing vertical and horizontal tracks in symmetrical array-based architecture usually not fully populated with the switch. Okay, see the horizontal or vertical channels is the routing space between two adjacent rows of any logic model. Okay, if you want to make the connection between the two adjacent modules, there will be some space. That space is called as horizontal channel or vertical channel. Right? This space is called as horizontal channel or vertical channel. Okay. So the routing channel is divided into set of sub channels. So in this region, the total region is called as routing channel or channel region. It is divided into set of sub channels. Okay. Sub channels are distinguished by the relative length of their segments. Depends upon their relative length of their segments. The sub channels are distinguished. Okay. Each sub channel consists of set of equal length routing segments. Here equal length, right? But in the case of row-based architecture, it is unequal length of segments are divided. Okay. And then the figure you can see here, the horizontal channel. This is the horizontal channel 1, it is 2, it is 3. We have 3 sub-channels, namely single line sub-channel, double line sub-channel and long line subchannel. Okay. Single line subchannel means it consists of single length segments, right? It consists of single length segments that form a horizontal and vertical lines that intersect at switch modules, right? Double line subchannel contains double length segments, right? And this length of the segment is twice as long as the single length one, right? And third, long line subchannel means it contains the segments that run entire vertical and horizontal channel. It does not contain any switch. The long line channel does not contain any switch, right? It will run through entire vertical as well as horizontal channels. And then we are going to see the just we can compare the two nets, net 1 and net 2, both are having equal geometric distance. But out of these two nets, which one is having lesser delay means, we can see both are having equal distance only. But net 2 having the more number of switches. Three switches are used to make the net 2 connection, but net 1 there is no switches used. So already I told you the objective of any routing is to use very less number of programmable switches. So net 1 always produces the lesser delay when compared to net 2. Okay. So with this, I can wind up the session 2.